I have you loud and clear.
Hello. Welcome. Science.
And that is to say,
physics,
medicine,
nature,
or
space, time,
the brain,
life, the universe.
This week, what makes people snore and can we control it? Is there a food group that is the most evil? And how does exercise help you to build muscles? And what's the best way to go about it? Yep, we're kicking off the year trying to get things right, and we're taking on the health-related questions that you've been sending in. I'm Chris Smith, and this is The Naked Scientist.
The Naked Scientist podcast is powered by ukfast.co.uk.
Well, let me introduce the panel of big brain people who are going to answer your questions for you. Dan Gordon is an exercise physiologist. He's at Anglia Ruskin University. He's also a Team GB Paralympian medalist. So as you were pegging it around the track, what was your sport, cycling?
Yeah, I was a track cyclist.
Yeah. Were you actually applying the principles of physiology to think, I know what this is doing to my muscles, I know how to perform better?
Yeah, it was never a good thing to have because actually you knew actually what was coming and you knew how much it was going to hurt. So yeah, part of it was that, and part of it was thinking, God, I don't really want this. So yes.
A lot of psychology and psychiatry in that, which is ideal because sitting next to Dan is Tom Mole. He's a psychiatrist at Cambridge University. He specialises also in wellbeing and mindfulness. Tom, very warm welcome to you. First time on the programme.
Thank you for having me.
So tell us a bit about your sphere. You're doing a PhD in mindfulness.
Yes, so I'm looking at the long-term outcomes of mindfulness. Having spent most of my free time at med school going around the world to learn meditation, I'm sort of putting that into practice into some of the research now.
I met a Buddhist monk who actually volunteered for a number of these studies where he would go into a brain scanner and be scanned while he was meditating. I was more baffled by the fact that he managed to meditate in an MRI scanner, because it's like laying in an oil drum with someone hammering on the outside with a sledgehammer, isn't it?
Yeah, I think that's testament to quite how good he probably was that he could still stay calm in that state.
So that's Tom. Sitting next to Tom is Sian Porter, someone who will always make people in a room nervous because, Sian, you are an expert on what you should and shouldn't eat.
Thanks, Chris. I'm a dietitian with the Health Professionals in Nutrition, and I'm spokesperson for the British Dietetic Association.
And Nick Oscroft is a consultant physician. He's at Papworth Hospital. Your area of expertise, Nick, is sleep. How do you study sleep? I mean, do you literally admit people to hospital and watch them sleep? What sorts of things are you measuring?
Well, a lot of our work is to do with sleep apnea, which we can do predominantly as an outpatient. But yes, we do also have access to polysomnography, which is admitting people and studying them overnight. We video them, measure their brainwaves, other bits and pieces, and try and work out what their problems are and a diagnosis and a plan to try and help them with their problems.
Sian, let's kick off with this question for you, which has come in from Harriet, who says, do any of the fad diets that are out there have any scientific basis, and are they all safe?
Well, this really is the time of year. There's hundreds of fad diets out there, particularly at the moment. Often there is a grain of truth or some science there, but often it's been extrapolated. It's been either misinterpreted or it's been bigged up beyond its means. And if you take something like eating chilies, which will raise your metabolic rate, that's something that we've observed, say, in a lab, and then you might have observed it in animals, but no human studies have been done. Or if they have, they might just be done on very small amounts of people.
Maybe sweat quite a lot when I
but then the amount that you have to eat, you're talking about 50 plus chilies, so nobody can physically do.
Dan's nodding. He obviously likes curry as well, actually.
Yeah. And there are dangers because often many of them tell you to remove whole food groups, which in the short term might not do you any harm, but in the long term is going to. So thinking about things like starchy carbs, things like fibre, which affect your gut health, they obviously can put your diet out of balance, which means then you might be overeating certain things and undereating. Calories can be too low, so you can be, especially if you're having to work and perform, then you might just not have enough energy. They can be socially isolating. They can be very expensive, so absolutely wouldn't recommend them. If something sounds too good to be true, it probably is, and if somebody's trying to sell you something, beware.
So Dan, when you're exercising, do you find that the diets you end up having to consume to perform at your optimum on the track, are they actually healthy diets or not?
I think if you look at them in relation to a conventional diet, then they look quite different. And I think one of the things that we see in sport is that the diet has to fit the energetics of the sport. So the recommendations for, say, a track cyclist would be very different to the recommendations for a marathon runner or even an ultramarathon runner. I mean, I was horrified when I worked with ultramarathon runners because I had made the assumption that we understand anything about nutrition. Suddenly these guys, it was nothing to do with carbohydrates. It was all just to do with energy intake. And so cheeseburgers. It was whatever they felt like they could consume. So for track cycling, we would view it as being a healthy diet, and you'd try and make sure that you've got the vegetables and you've got the right balance. But actually, we were very much about carbohydrate and protein.
Thank you, Dan. Nick, wrap your ears around this question.
What happens in our brains to make us fall asleep?
What actually governs the transition between being awake and being asleep?
Within the brain, there are neural networks that promote wakefulness and there are neural networks that promote sleep. To demonstrate that in everyday life, we're all aware that certain antihistamines can make you sleepy. They block the histamine system in the brain and that makes you sleepy. And we know that histamine is one of the alerting systems within the brain. And there is this switch within the brain, just as you're getting drowsy, trying to drop off to sleep, where the alerting systems and the systems promoting sleep inhibit each other. And it's almost like a switch where you switch between one and the other one to initiate sleep. We can measure that in a sleep lab looking at brain waves. So we measure EEG, and that shows that actually you start off with quite high frequency brain waves. And as you drift off to sleep, go into stage 1 non-rapid eye movement sleep, which is generally the first stage of sleep you go into, that they start to reduce in frequency. And then you go into stage 2 sleep, where there's some very specific things we can see in an EEG, things called sleep spindles, things called K complexes. And then as you get deeper into non-REM sleep, you'll go into a very higher amplitude but lower frequency slow wave, which we can see slow waves in the sleep, which is what we call them. And then REM sleep actually is a very active state of mind where your brain's active and your eyes are flicking around. So as you're dropping off to sleep, we can see it happening as you're getting drowsy on the EEG signal. But it's really this switch that really takes you over the edge.
And any tips for giving people a good night's kip? That you could just a few bullet points?
I mean, my top tip would be routine. Going to bed at the same time every day and getting up at the same time every day really gives your body a chance to allow all the hormonal changes and other changes that need to happen to aid sleep onset and sort of natural waking in the morning. Giving yourself sufficient time in the current environment is also very important. I see, well, most of the population tends to be slightly sleep deprived, and that really doesn't help, both in dietary terms, energy intake. It all has negative effects if you're sleep deprived.
Nick, thanks. Now, I hope you're not finding the programme too altogether stressful, Tom, because I've got this question for you that's been sent in by Shane.
I've heard some stress is good for you. How do you know how much is too much?
Great question. I like it because stress is kind of talked about in a way where, it's always a bad thing or evil. But if you're going to be really scientific about it and you took away all stress from your life, you'd soon realise that you were understimulated, bored and restless. So then the question goes, then, well, what happens if you're overstressed? And we're probably all familiar with that feeling that we've got too much on and that we're perhaps beginning to shut down and feel a bit too stressed. So my answer to that would probably be to find your personal sweet spot. And it actually follows this Yerkes-Dodson law, where a little bit of stress or arousal in the scientific terms is helpful, but too much and our performance rapidly goes down and our ability to enjoy life. So in terms of sort of practical solutions, I might say that you could probably look out for some of the red flags that you're getting irritable, you're feeling that you can't cope, but also to ask people around you, because it's often the person themselves can't always tell if you're actually swamped. So maybe find someone you trust, a friend, family, a colleague, to report back to you, actually, yeah, you're looking a little bit too stressed, and to check in with yourself. And obviously there's health professionals and your GP if you are concerned.
So a little bit of stress is good. Too much stress and you begin to feel you have no sense of control, and that tends to be deleterious to your life. Is that reflected in biochemical measurements we can make of people? If we measure hormones and so on, do we see that played out?
Yes, exactly. So the stress we feel every day has this corresponding hormonal story that's happening in the body in the background, cortisol being the main stress hormone. And we know that things like cortisol can prevent certain brain areas from growing and adapting with memory. For example, the prefrontal cortex, that big blob at the front of your brain that helps us with the more complex tasks, and the hippocampus, which is involved in memory. So it's not just the stress you feel, but it will be having an impact on your mind and your brain, your ability to remember things and get on with life. So yeah, it's really important to get that balance, that personal balance.
Thank you, Tom. Dan, Chris would like to know this.
What is it that makes muscles go bigger when you exercise?
So how do you build muscles up, and what's the best way to do that?
So the key to this is that not all exercise does this in many ways. So it's very much about the load that you apply through the muscle. It's the same phrase. It's quite interesting. We talk about stress, and we have to apply stress, and it's a biological stress that you apply to the muscle. So when we think about the muscle adaptation, which in essence is the idea of hypertrophy, which is that the muscle in itself bulking up, what's actually happening is that it's the muscle in essence resisting the load that's being applied to the muscle. So if I apply a greater load to the muscle, then I'm going to create a greater stress. If I create a bigger stress, I produce more fatigue. If I produce more fatigue, I produce more biological adaptation. Now, the trick with it is that if I'm applying only a light resistance, so for example, I go to the gym and I lift a very light load, I can do lots and lots of reps. And actually what I train there is more the endurance of the muscle. If I want to make the muscle bigger, actually what I've got to do is apply a heavier load, but I can only do less reps. And what starts to happen is, one of the misconceptions is that we increase the number of muscle fibers. It doesn't happen in the human. What we actually get is a hypertrophy. We get an increase in the size of the fiber. And the thing that fascinates me about this is that if you take somebody who's never done any kind of strength training before, they will actually report quite quickly that they feel like they're getting stronger. And in fact, the load that they lift increases quite dramatically, but the muscles haven't got bigger at all. And the reason for this is what we start to see in probably the first 8 to 12 weeks is you get a heightened neural recruitment of the muscle. So we actually recruit more motor units. And over time, as the muscle starts to adapt and we get an increase in the cross-sectional area of the muscle, the neural recruitment starts to decrease. It'll be heightened compared to where we were at baseline, but it starts to decrease. And that's because we've engaged more of the muscle fibers, and we've now got the fibers are actually larger in size.
So when you say the neural recruitment, say I want to lift something, message comes out of my spinal cord and activates the right muscle groups to do the lifting. But as I train that response, at least in the early stages, rather than say 10 different groups of muscles fibers turning on, I might be able to train myself to turn on 20 all at the same time, and I'll get more force out even though I haven't made the muscle physically stronger.
Correct. The reason for that is partly because we don't know what the movement is. So the movement is actually alien to us.
So is that my nervous system rewiring itself to make that movement occur more optimally then?
It's, in essence, that's exactly what's happening. I mean, people talk about muscle memory, which I don't think is a great phrase, but if we think about it in that concept, the first time you do an action, you go and see somebody who's doing Olympic lifting, they're lifting a bar, never done it before. The bar is moving all over the place, there's poor coordination. So what we do is we recruit what are called the synergists, which are the support muscles. But over time, the prime movers that are involved in the action start to become dominant and the synergists start to decrease. So that will explain why the neural recruitment goes down, because we're not recruiting these additional support fibers.
So if we want to be able to bulk up a muscle to get the best of both worlds, we need to train not just the reps, how long we can go for and get good blood supply into the muscle and so on, but you've got to stress the muscle in terms of lifting very heavy loads beyond what you would be comfortable lifting in order to stimulate it to grow more.
Correct. And the key to any adaptation, it doesn't matter whether it's strength or endurance, is you have to move beyond the biological habitual level. And the greater the amount of fatigue you produce, the bigger potentially the biological adaptation that you're going to produce. So if I want to get a hypertrophy of the muscle, I've got to lift around about 85 to 90% of my maximum effort. Actually, strength training is really easy. It's just two numbers. It's 3s and 5s. So if I want to get hypertrophy, then all I've got to do
This is muscle getting bigger.
This is muscle getting bigger. All I've got to do basically is 3 sets of 5 repetitions. Like I hear gym coaches now going, no! If I actually just want to increase the pliability of the muscle, I want muscles that are stronger but not necessarily bigger, I just do it the other way around. I do 5s of 3. And so if I'm doing 3s of 5s, so that's 3 sets of 5, I'm doing more reps, so I can actually afford to I'll do a lighter load. If I do it the other way around, I'll do it at a higher load. And that changes the biological adaptation.
There you go. Now you know what to do down the gym as part of your New Year workout programme. Thank you, Dan.
What's remarkable is that in the human embryo, for instance, there's about 10 or so of these pluripotent cells in the 7-day-old embryo, and these 10 cells make all of the different trillions of cells in our bodies.
In this month's Naked Genetics podcast, we take a trip back in time to find out about early development. Plus, the importance of placentas, why the age of your womb rather than your eggs matters, and a video game-inspired gene of the month. Listen and download now at nakedscientist.com/genetics.
Still to come on The Naked Scientist this week, we're asking, do bacteria sleep? What's the worst food group? And does mindfulness really work? But before that, as it is New Year and we're all trying to be a little bit more healthy, we've asked each of our members of our panel to come up with a top tip from their field. So, Sean, let's kick off with you then, first of all. What's your dietary top tip?
I think it is to eat more vegetables. Really, every meal that you have, think about where are the vegetables. So breakfast, you could be having something like mushrooms, tomatoes. Your lunchtime, when you go and get your sandwich, instead of having a packet of crisps, have a side salad. And then your evening meal, get some vegetables in there. Another good rule is to put your vegetables on your plate first. So fill half your plate with vegetables, and then there's less space for your carbs and your protein. Have them there. But if you put it on first, because classically you plate up your meat, you plate up your carbs, and then there's this tiny little...
Everyone is nodding.
Yeah, there's this tiny little thing. And the other thing is to eat, have some variety. We do tend to get into a bit of a vegetable and fruit rut, and there is huge variety, and things like frozen vegetables can really be your friend, whether you're catering.
Are they okay then, frozen vegetables? Because they get a bad rap. People say, oh, it's not fresh. Are they okay?
And sometimes they can be more fresh than fresh, because they might have been frozen actually where they've been picked on site, whereas other vegetables might have had to be transported, and heat and light's going to affect some of the vitamin content.
But why are vegetables good? Why are you banging the drum for vegetables? Because many people say, I hate vegetables, I never eat them, they're the devil's thing. But why are they good?
They're a great source of fibre. So obviously fibre helps keep your gut healthy, reduce your risk of certain cancers. Physically, it will help fill you up. So when you're having that meal, it will fill you up. They tend to be low in calories because they have a high water content, so you can eat a lot of them. They're rich in vitamins and minerals, and also they're rich in phytochemicals, plant chemicals, which seem to have health-giving properties.
Dan, your top tip for 2018?
Any activity is better than no activity. I think we get caught up, a bit like we were talking about with the diets, we get caught up in fads and new trends. And actually, what people should think about is the amount of time now that we spend sitting. And actually, even if it just means at work, holding a meeting standing up, or having a walking meeting, or just at lunchtime, rather than getting the lift downstairs, walk down the stairs and walk back upstairs. I think it's about, and excuse the pun, it's about taking small steps.
Or big steps.
Well, potentially big steps. It's certainly not about trying to run before you can walk, another pun there. But it's really about the fact that we have to start slowly. And the key to exercise and the key to getting fitter is it's like building a pyramid. You have to put the foundations in first. And I think we get all excited about this kind of really fancy stuff where we get all these intervals and this really short duration work. Actually, put the foundations in first, which is just about being physically active. Then you can move on to that additional stuff.
And a mindfulness tip from you, Tom?
Well, I would say that in today's modern life that's so frantic and busy and littered with so much multitasking, why not give yourself 10 minutes of you time every day and try and think of a way to put it in the morning or your evening routine and use it as an opportunity just to do one thing and to give yourself that gift of unitasking or a break from multitasking. Perhaps go off grid, turn on aeroplane on your mobile, turn off the notifications, calls, emails. Try and rebalance that sense of giving yourself some relaxation time, and perhaps learning a new skill like mindfulness can give you that evidence-based bit of a recharge for you and to rebalance how you're doing in your day.
We'll learn more about it a bit later on in the programme. A tip from you, Nick?
I would probably say, as I would, prioritise sleep. Sleep tends to get stuck in the corner. It is often the thing that people say, well, I'm really busy. What am I going to miss out on? I'll miss out on an hour or two sleep because that's a bit of a waste of time. I'm lying there unconscious, not doing anything, not getting anything done. But actually, if you get into a good routine, make sure you get sufficient sleep for you, which is variable depending on the individual. You'll be much more productive during the day and much more efficient, and you'll get a lot more done. So actually, if you spend that extra 1 or 2 hours sleeping, you'll probably be better for it at the end of the day, and you'll get everything you want done in the day more swiftly.
Thank you, Nick. Now, talking of sleep, we've got this question, Nick, for you from John.
Why does snoring exist? Shouldn't it have been selected against? I know my dog snores like anything, but does it exist in wild animals?
So that's a fantastic question. And one of the things that struck me about snoring is that evolution. You said, why hasn't it been evolved out? Well, the shape of our faces has changed quite considerably since we've transitioned from being apes into hominids and then into humans. That's aided speech. We've changed our diets. So I think all these changes may have predisposed us to a degree to snoring. What is snoring? It's turbulent airflow through your upper airway. Lots of things can make that worse. Obesity is a big problem. We know that weight gain tends to make snoring worse.
Why?
Why? Because you lay down fat as well as peripherally, internally, around the larynx and the upper airway, and that narrows the upper airway. Also, most of us, when we go to sleep, the muscles in our pharynx relax, so the upper airway, the muscles relax. And if you fat load that, it will shrink in volume, and therefore you'll get more turbulent flow through your upper airway. And also it can predispose you to medical problems like sleep apnea, where actually the throat shuts down during sleep because the muscles become too relaxed, and that causes lower quality sleep and daytime sleepiness. And alcohol and various other things that people do make snoring a lot worse. In terms of why hasn't it been weeded out in evolution, I was interested by that. One theory I thought about was, if you snore, do you keep people around you awake? Does that actually protect you in evolutionary terms? It's a controversial thought.
So you're saying it's been selected in? If your husband's snoring and you're therefore kept awake all night, then you know that you can wake him up if any danger appears. That's a brilliant suggestion.
It might be a selection pressure. I don't know.
Dan?
Well, I was just interested on that because I think part of the question was to do with animals. My dogs both snore, and they're terrible at it. But I was just wondering, now you've brought that up about this selection, it's made me almost rethink, because in the animal kingdom, you would have thought it was almost counterintuitive, the fact that you've got an animal that's snoring. But I'm just wondering, actually, whether it's the pack animals that snore. And actually, if we take the solitary animals, I wonder if the solitary animals don't snore, because I like that idea, the fact that it's almost, there's somebody in the pack that's more alert.
Well, I've been to zoos, and I've seen many animals snore. With dogs, I don't know if because they've been bred over time for certain characteristics, and we know certain bad characteristics have been bred into dogs in terms of the shape of their snout, so we might be responsible in part for making dogs snore by the way we've selected them.
What about doing something about it? You've mentioned some of the points, so you could reduce your alcohol consumption, weight loss, presumably if you remove some of the fat from around the internal tissues. And I didn't realise we accumulated fat in the way you're saying inside and narrowed the airway, but that should help too. But is there anything else if someone's a really bad snorer that they could do about it?
Weight loss is normally top of the list. Also, avoiding supine sleep, so avoiding lying on your back whilst you are asleep. That almost always tends to make...
You have a lot of choice if you're asleep, though. You don't really dictate what position you're in, do you? Can you?
You can do. There's various strategies you can adopt.
So the whole stitching cotton reels and fur cones into the back of your pyjamas, that idea. Is that what you're getting at?
Certain people do that. One of my more ingenious female patients puts her bra on backwards and puts a...
tennis balls in there or something.
Oh, well, it's a rubber dog ball. It's quite spiky.
Oh,
and that keeps
strong incentive to
that keeps her off her back. So that was quite inventive when she told me about that. I've suggested that to a few gentlemen, but they've blanched at that thought.
I'm not surprised.
Some people use foam wedges or pillows to stop themselves rolling over to their back. Partners are often helpful.
An elbow.
Indeed.
Yep.
There are biofeedback devices you can buy that vibrate when you start snoring loudly and get you to roll off or change position to help with that. If you want to try something a bit more invasive, there are devices called mandibular advancement devices. They're devices that go in the mouth, fit the teeth top and bottom and pull the bottom jaw forward. So they are a way of reducing snoring volume. And also we use them to treat sort of mild to moderate sleep apnea. But sometimes it's just a fact of life, I think.
Just start with the simple stuff and build up from there then.
Indeed.
Nick, thanks very much. Now, we've got this question from Lucille for you, Tom.
What is mindfulness, and is there evidence that it works?
So, mindfulness, what is it and does it work? What's the evidence base?
So, mindfulness is a simple skill that we've all got as humans to be aware of the present moment and to not judge it and just to allow it to be there as it is. Historically, it's a practice of being aware that's been around for about 2,500 years, originating out of South Asia. So, historically, there's a beautiful lineage of generation after generation of people saying, well, actually, if I just focus on what I'm experiencing right now, so that might be the sound of my voice as you hear it, or the sensations of your body right now, if you're sitting down or lying down, and just accepting them. And that teaching has been really passed on for generation after generation. And over the last 10 to 20 years, it's been more and more scientifically validated. In particular, it's most effective for stress reduction, but it's also been shown and is in national guidelines now for preventing mood problems and depression, and also for helping people cope with anxiety and sort of forming new habits and breaking habits, whether it's overeating or whether it's actually smoking. So it's quite an adaptive tool. But I do have to be careful not to overstep the evidence base. And I think if you ever hear someone saying that meditation or mindfulness is something that can cure everything, a panacea, then be careful that everything has its limitations. But certainly it's a very strong technique for stress reduction and improving your sleep. So I think that on balance, there's an emerging evidence base that's exciting, and I think I'd recommend just getting out there and trying it for yourself.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Now let's take a little break from taking in people's questions to ask you some questions that we've come up with. Teams, so we're going to have a little quiz just to break the flow a little tiny bit for you. So I'll ask you a question, you can confer. We're going to have two teams. Team 1, we're going to have Nick and Sian, and then Team 2, we're going to have Tom and Dan. And basically, the quiz theme is health. We've got 3 rounds, and round 1 is diet fad or diet fiction. So can you separate the real diet from the one we've made up? So over to you, Nick and Sian. We've got 2 diets to choose from. The walking diet, this is where you can eat anything you like, provided you only do it while you're walking. Or the 5-bite diet, this is eat whatever you want, but you're only allowed 5 bites out of it. Which is the real diet?
The 5 bites is real.
You're going for 5 bites?
Yeah.
You concur with that, Nick?
I do.
You get a bing for that. Well done. Yeah, it's absolutely true. The 5-bite diet does exist, but the walking diet doesn't. Maybe the walking diet should exist. It sounds like a better solution to me. Right, the next one for you, Tom and Dan, the blood type diet. You can regulate your intake based on your blood type, or there's the ring diet. If you can fit it through a ring, you can eat it. What do you think of that one?
Oh, they both sound crazy.
They do sound absurd. That doesn't mean that neither of them exist, though.
I would.
The blood type, a lot of people don't know that one, so I'd hope that would be the false one.
Let's go for the ring one.
You're going rings?
Yeah. Oh, man.
You're getting a what. The actual answer is the blood type diet. Now, we actually found this quite hard because every time we made up a diet, we'd actually find out it did exist. So it was quite hard. Anyway, let's move it on. Round 2, this is called false alarm. Which of these alarm clocks is actually being sold, Sian and Nick? Is it an alarm that screams and runs around the room so you have to chase it and that gets you out of bed, or is it a rubber glove that slaps you repeatedly around the face until you get up and silence it?
I'm going to go with the more ridiculous option, which is the rubber glove that slaps you round the face.
Sian, agree with that?
Yeah, absolutely.
No, the rubber glove, unfortunately, is a fiction. One of them does exist, though, because inventor Simone Gertz has built one, but unfortunately, or perhaps you could say fortunately, they aren't for sale. Right, over to Team 2. Which of these exist and which is a fallacy? An alarm clock in the shape of a gun. It will only turn off once you successfully shoot the target. Or an alarm clock in the shape of a bomb, which you have to successfully defuse every morning, and it's getting louder and louder. What do you think?
Both sound quite dangerous.
Yeah, I think I'll go with the gun. It sounds relatively plausible.
Let's do that.
You're going gun?
Let's go with the gun.
You get a bing bong for that. Yes, the gun-shaped alarm clock is the actual one available. Does it, Nick, you're the sleep expert, does it make a difference how your alarm clock wakes you up in the morning?
There's some evidence that if it wakes you up during REM sleep, that's probably not such a good thing for you.
So if you're having a dream...
If you're having a dream, yeah.
Why is that bad?
Because I don't think the human body likes being woken up out of dream sleep, and generally the human body likes to wake up naturally. Unfortunately, most of us do wake up with an alarm, and most of us use our mobile phones, which tends to be the thing that everybody uses these days.
So an alarm clock synced to brain waves that could work out when you weren't sleeping and therefore more sympathetically wrench you out of sleep would be better.
Yeah, there are devices that attempt to do that, but how accurate they are in measuring sleep stage, I'm not so sure.
Right, round 3, it's all to play for. This round is called Exercise Lies. So, Team 1, which is the real exercise product? The Hawaii chair moves in small circles while you work and it theoretically tones your abs. There's also the Alaska shoes. These are shoes with large weights that move around inside the sole and they theoretically tone your leg muscles. Which do you think is the real one?
I don't know. I like the idea of the Hawaii hula hoop chair,
Yeah.
though. So, shall we go for that one?
Going chair?
Yeah, let's
Chair.
make sunshine.
Yep, the real answer is the Hawaii chair, although the company who provide it are unsurprisingly no longer in business. Now, last question for you, Dan. You've got to stay in the game, you, Dan and Tom. Which of these is a real exercise fad? Hamster wheeling. This is running around in a specialty-built hamster wheel, or prancer-sizing. The aim of this is you have to run in the style of a horse to burn off calories. Which do you think? Running in a hamster wheel or running around like a horse prancing about?
I think I've seen the hamster wheel.
You're going for
Yeah,
hamsters?
hamster wheel.
Hamster wheel.
Yeah.
No,
Oh,
I'm afraid
really?
you haven't got it. The answer is actually prancer-sizing. Hamster wheeling might have to wait a little while. It seemed like a good idea to you, Dan? These
No,
sorts
but
of
I actually
exercises?
thought I'd seen it, and maybe it was on one of those crazy shows like Jackass or something. But I certainly thought I'd seen it.
Must be true. No.
Yeah.
Well, well done, Team 1. You have won. You are the Naked Scientists' Big Brains of the Week, and you go home with a prize beyond price, which is knowing you have your reputations intact. Now, Nick, back to this question, which is coming from Lizzie. Lizzie wants to know, why are some people morning larks while other people are night owls? What do you make of that? Lizzie says she doesn't think she's either.
I mean, there are genetic studies looking at families that show there are some genes that predispose you to being a lark or an owl, but it's not cast in stone. As a parent, and as I'm sure other parents experience, is that as you journey through life, your tendency does alter. Most teenagers do tend to go towards the night owl stage of things, as I know, as I dragged my 13-year-old daughter out of bed this morning at about 11. And then as one ages, one tends to go to more morning phase and need less sleep. So it does tend to change as you go through your life. But some people do have a stronger predisposition to be one or the other. And some people are neither. And it depends on also external factors, whether you're a shift worker, whether you have to get early for your job. And the external factors are probably more important because, unfortunately, most employers won't let you stroll up late for work just because you happen to be a night owl.
Well, they will let you for as long as they'll employ you, which means
Which
ultimately
may be a short
may not be
period of
long.
time.
Yeah. Now, can you help out Juan, please, Sean?
We hear a lot about sugar, salt and fat. Is there a single worst culprit for bad health?
So, food public enemy number 1. What is it in your book, Sean, please?
Well, I'm really against viewing as single nutrients because, for a start, you need to have a healthy relationship with food. So if you sort of thinking about one type of food, then it leads to the thinking about good and bad foods, which isn't really a healthy way to view things. As I said before, food comes as packages and you want to take a whole diet approach because obviously sugar has been public enemy number 1 for probably the past couple of years, and that's led to so much confusion because not all sugar's the same. And really the sugars that we should be worrying about are what we call free sugars, or the sugars that are added. And that includes things like table sugars, but it also includes things like syrup, so agave syrup, maple syrup, date syrup, and fruit juice falls into that category as well. Sugar that you find in the cell of fruit and vegetables, and lactose, which is the sugar that you find in milk and dairy products, that's absolutely fine. And I get people come to say to me, oh, I don't have yoghurt because of all the sugar in it. Actually, about 5% of the sugar in yoghurt is lactose. So if you're looking on the back of a yoghurt, 100 grams, about 5 grams of that will be lactose. So it's about, you need to have a mixture of nutrients, of fat, protein, carbohydrates.
What sort of amounts relatively of those?
Well,
because when I went to medical school, people used to say you should get, maybe half the calories in the day should come from fats or something, and then maybe about a third from carbs, and then 20% from protein, something like that.
Yeah.
Does that still stand, or have we moved away from that?
Yeah, there's ways of looking at it, and if you're looking at population recommendations, if you're looking at basing it on calories, then it's still around 50% of calories from carbohydrates, about 30% from fat, and about 20% from protein. But that's population, so it varies so much from individual. But that's really doesn't help you. You know, you're not going to get your calculator out and work out that like carbs got 4 calories per gram, so 50% of my energy, 100. So I think a much simpler way of it is thinking about when you're making up your plate, going back to having half your plate fruit and vegetables, about a quarter some lean protein, and don't forget things like beans and pulses, and about a quarter for your plate. So we're talking probably about the size of your clenched fist of starchy carbohydrate, preferably high fibre, so things like whole grains, brown rice, brown pasta, potatoes with skins. Try and have some protein at every meal because your body likes it better if you spread it out through the day. Stay hydrated. With fat, you want to watch saturated fat, which is the one that can raise your cholesterol, and raised cholesterol is a risk for cardiovascular disease. But like I said, if you aim to have at least 5 portions of fruit and vegetables, some starchy carbs, some fibre, and watch your portion size, that's the other thing.
Thank you, Sean. Now, they say that life is like being on a treadmill, Dan. This one, very pertinent from Ricky.
Is there a difference between running outside and running on a treadmill?
Can you get the same benefits from hammering along the pavement as you can from jumping on a treadmill in the gym and vice versa?
In the broadest sense, yes. So in the broadest sense, you will get cardiovascular adaptations and so on and so forth. Actually, if we look at it metabolically, there's quite a big difference. If you run on a treadmill and you just use a treadmill in the gym and run at the same speed, so let's say you monitor your speed with a GPS watch outside, the amount of work that's been undertaken by the muscle is actually quite significantly different because the treadmill is doing quite a bit of the work for you. And what we actually find is that there's an increase in what's called the eccentric phase of the muscle action. That's the lengthening of the muscle. Whereas when you're running outdoors, that phase is reduced. Now, why is that important? Well, the eccentric phase of the muscle actually uses almost no energy. So one of the ways that you can combat that is set your treadmill gradient at 1%. A 1% gradient increases the metabolic cost. And there was a beautiful study done back in the late 90s where they compared outdoor running to treadmill running. And they found the same metabolic cost if it was on a 1% gradient. However, that only works if you're running for, say, a short period of time, because once you go beyond X amount of time, you now start getting into the issues of thermoregulation. Because when you're outdoors, of course, one of the things you've got is the ability to dissipate heat into the environment. When you're running in a gym and you're on a treadmill, that heat dissipation is much, much harder because you're already running in a warmer room and we haven't got the ability to remove the heat. And so the net result is that actually, although you'll get the grand cardiovascular responses if you run, because you're just running and you're running at the same relative speed, actually there are significant effects on muscle recruitment patterns between the two and significant differences for thermoregulation and even potential for things like dehydration between the two.
So would you advocate then, save your money, just use the free gym called the stairs, the park, the road?
Yeah, I mean, I think it's quite an interesting one. I mean, it's often made me wonder, why do people go to the gym just walk on a treadmill? And I can understand it to a certain degree because I think there's obviously a social side to doing it. But actually, I think in the end, yeah, it's free and the overall response is probably going to be better if you just don't use the treadmill.
Thank you, Dan. And after that, you probably feel a bit sleepy. So here's a sleep-inspired one for you, Nick.
Do all animals sleep? And do any plants or bacteria?
So all mammals and birds sleep, as far as we're aware. Reptiles also sleep, but it's a bit more tricky to measure, but we think they do. As you get to more primitive organisms, fish, we know zebrafish have a resting state. There's lots of scientific data about that, and they're often used in experiments to investigate sleep. Plants do have a light-dark cycle, but they don't have a central nervous system, so I'm not sure if they specifically sleep, but they clearly are sensitive to their environment. And then we get down to very primitive things like bacteria. Most things exhibit a resting phase. Whether we could call that sleep in a bacteria, I'm not sure. But what I would call sleep in terms of it being a quite a regulated process that happens at a certain time that you have to catch up with if you miss it, probably is something that happens more in the higher organisms rather than all the way down the food chain, as it were.
What about the sorts of creatures like marine mammals that apparently can sleep half their brain at a time? Is this true or is it a myth? And if it is true, how do they do it?
So there is evidence that they do have so-called hemispheric sleep. in marine mammals, as you state, but also other animals that need to keep swimming, for example, sharks, because they need to keep seawater going through their gills to keep them oxygenated. You can make cats have hemispheric sleep if you do the right operation on them as well in scientific experiments. So yeah, that is true.
It's called hemispheric sleep because just one hemisphere of the brain is
just one half.
deactivated into a sleep state at one time.
Yes, and that has been studied. And generally, they tend to have non-REM sleep rather than REM sleep. The reason for that being when you go into REM sleep, your body tends to actively paralyse you. Half of you becoming paralysed whilst you're swimming probably wouldn't help.
But bacteria, loose definition of sleep, but they do have a metabolic bit of downtime.
Yes.
Thank you, Nick. Right, question for you, Sian. This is from Emma.
Is there any benefit to going gluten-free if you're not gluten intolerant?
What do you think?
Well, thanks, Emma. That's a very popular one. No, in fact, gluten is a protein you find in grass-related things like wheat, barley, rye and oats. And what it does is it provides like a viscous elastic network to give structure to those things. Now, about 1% of the population suffers from celiac disease, which is an immune disease, which means they can't tolerate gluten. And then we think about 6% of people might have what we call non-celiac gluten intolerance. So they have the similar symptoms. Now, if you think about a lot of our diet can be wheat-based, and some people maybe are having something like a cereal for breakfast, sandwiches for lunch and pasta for dinner. So there is this theory that perhaps there's a threshold. And the best way, I would say anyway, for a healthy diet is to mix up your carbs. So have potatoes, rice, pasta, to have a variety. You get plenty of gluten-free foods now, but they're not necessarily more healthy. And actually,
they're also not very tasty.
No, because if they're missing that structure, then they'll have to adapt the recipe. They all can be high in fat, sugar, salt. They can be low in fibre, low in protein. And research has shown that often people who are avoiding gluten are then adding less healthy choices, maybe like cakes and biscuits, more into their diet.
Can I just ask, what proportion of people think they have gluten intolerance? And what proportion, if we go and test the population, probably really do have it?
Yeah, there's various studies that have looked at this, but a figure that's quite often quoted is about 30% of people think that they have some kind of allergy or intolerance. But actually, when it comes down to it, it's probably somewhere between, like I said, 1 to 6%. People forget things like, if you take symptoms like bloating, if you think about a meal that you've eaten on a plate, that food's got to go somewhere, so it will go in your stomach. If you think about when your stomach's relaxed and then you're putting the food in it. So it's normal parts of digestion that people seem to have forgotten. And also things like lack of fibre can actually produce gastro symptoms. So I think it's maybe things that should generally people are misinterpreting. The other interesting thing that's coming along is something called FODMAPs, which is fermentable oligosaccharides, disaccharides, monosaccharides and polyols, which are types of carbohydrate which do get fermented in the large bowel and can produce problems in some people. If people want to follow a FODMAP diet, you can't do it lightly. Go and see a dietitian. Yes, it's something that can be very useful for people in IBS and improves symptoms in about 75% of people, but you have to follow it properly.
Thank you, Sian. And of course, we mustn't conflate IBS and celiac disease or gluten intolerance because they are quite different things, aren't they? Let's try and sneak this one in that's just coming for you, Dan.
What is high-intensity training and how does it work?
So we talked about various forms of training. We've talked about treadmills. So now you're on to HIIT or high-intensity training. What is this? Is there any justification? What's the evidence, etc.?
Okay, this is the big hot topic at the moment in terms of training. So this is the notion that we can get fitter faster. And it's really come about because there was some work done out in the US and in Canada where it was quite obvious that people were saying the biggest impediment to be able to do exercise was the lack of time. And historically, we've understood that interval training is actually a really potent stimulation for biological adaptation because you've got a high-intensity block and a low-intensity block. So actually, you can accomplish more than you would do if you're doing low-intensity exercise. There's a real rationale for doing this. The issue that really comes with HIIT is I think there's a lot of misunderstanding about what HIIT training is. So if we go back a little bit back into the late 90s, early 2000s, HIIT was really promoted as doing 30 seconds of maximal intensity exercise with about a 30-second recovery. Do it 4 times, 3 times a week. And lo and behold, after 4 weeks, we've got a biological adaptation.
Sounds too good to be true.
It sounds too well, and it probably is too good to be true. I think a lot of the issues lie in the vast majority of the studies that have been done in controlled conditions. They've only been done over short periods of time, and they tend to be done on the population group that you don't really want to try them on, which are students who are already relatively physically active. Actually, what we do understand is that interval training does work. If you look at elite athletes, they'll do intervals. But the key is that intervals only work if you've actually put the foundations in. So to get to do that high intensity work, we've got to have done low intensity cardiovascular work, because the key to intervals working is the recovery. And if you can't recover between the interval, in the end, what happens is that you in essence lose any of that biological gain. And then it becomes really interesting, because now we've got what's called sit. So sit is where the science has been fudged, which is, we didn't really mean 30 seconds, and that's not this kind of training everybody's into now. They're all into this really, really short 10 seconds of exercise and 30 seconds recovery. And I'm less convinced by this, because if we think about that in terms of
tell me the regime then. So what would if I wanted to do sit training, what would I do?
So if you want to do sit training, you would come in and we would set a resistance up on the bike, which is probably about 7.5% of your body mass. And then we would say to you that you are now going to sprint as hard as you can for 10 seconds. And I'm now going to give you about 20 seconds recovery. And I'm going to ask you to do that 10 times. And then you're going to do that 3 times a week. And the evidence that's come out from this, there were some studies that come out that showed improvement after just doing, and when I say improvement, we're talking about improvement in maximal oxygen uptake, which is our index of cardiorespiratory fitness after doing just 6
So
sessions.
that sounds like it's good for, say, muscle function.
Right.
What about my blood pressure? For taking exercise to lower my blood pressure,
Right.
taking exercise to reduce my risk of diabetes, stroke and heart disease.
Yeah.
What about those impacts?
And this is where it becomes really fascinating, because there's a lot of studies that are suggesting that actually if you do sit training, that it can reduce the incidence of type 2 diabetes. Suddenly the alarm bells go off in your head. You start thinking, really? And we're talking about after 8 to 12 weeks of exercise. I just don't think the science adds up. If I'm doing 10 seconds of training, then I'm training the high energy phosphates, the use of ATP and phosphocreatine. And although I've got a recovery in between those blocks, the majority of the work is short duration. So I can never quite make how that comes around to actually improving cardiovascular fitness. I can understand how in doing intervals which are at a lower intensity but a much longer duration, if we talk about 4 to 5 minute duration intervals, which is what, say, a Mo Farah would be doing, then it works. And you can understand then how the blood pressure is reduced, because you're getting that engagement in central cardiovascular drive. But if I'm doing these very short intensity efforts, I'm less inclined to believe the fad.
So stick to a sensible regime that you can stick to, so you can keep a routine, and just the mantra, some exercise is better than no exercise, is probably the rule of the day, isn't it?
Yes, it really is, yeah.
Thanks, Dan. Now, Tom, I'd just like to talk a little bit about the app that you've developed. So you're a psychiatrist and you specialise in young people's psychiatry, but you're also very interested in mindfulness, and you're doing a PhD in mindfulness.
Yes.
Can't be many of you.
No, not too many, although I think there's a growing recognition of mindfulness. And I came from the background that a lot of people were getting into mindfulness, but there was this assumption that you can't give feedback or measure mindfulness. And so if you were to go out and search for mindfulness app and to download it on their phone, most of the apps would just give an audio instruction. And it might give a script such as close your eyes and, for example, focus on the breath. And the problem with this is that if you imagine closing your eyes and doing an exercise for 10 minutes without any feedback, what you're really doing is you're impairing the mind's ability to learn from that process. Because you go out thinking, did I do it right? I'm not sure if I was concentrated enough. And then you might negatively appraise that and go, well, I can't meditate. Meditation's not for me. Or maybe I couldn't stop thinking about something I said to someone else, or going to the past or the future. And so what we've done in the Minds app, which gives the first meditation feedback within the app, is we've focused on playing a short bell sound to people when they are focused and when they are mindful in the moment.
How does it work? How does it know that?
We developed new technology where clever motion sensor algorithms in the phone can detect how you're breathing and when you're breathing by the user simply putting their phone on their abdomen, lying back in a chair somewhere comfortable, say a sofa or a chair in the room, And then as they leave their phone on their abdomen, that phone will slightly tilt and will oscillate, almost in a sort of sinusoidal pattern. And that basically tells an algorithm of how you're breathing. And then we just tell the user, just tap the screen whenever you breathe in. And so what we do is we compare, this is all very geeky, but we'll compare the gyroscope signal to when the user taps to work out whether it's a good fit, whether they're tapping just when they breathe in or whether they're distracted and dreaming of a Big Mac and or their sleep hygiene or something like that, and they miss a tap.
Because that's what happens to me when people say obsess about your breathing, really focus on it and relax. My mind is racing all the time, and the minute I get relaxed, immediately it creates all this mental space, which I then instantly fill with other rubbish and distractions, and instantly I am not concentrating on relaxing. So something like what you're saying, which gives you something to focus on, helps you to exclude all those distractions.
And so it's a concentration aid, and I think what you've described beautifully is what we call the default mode of the brain. So if I sit you in a room or anywhere in life and I tell you not to do anything in particular, the brain will automatically start mind wandering. And this happens about 50 to 60% of every hour of every waking day of your life. And so this tool is a way of helping you to become mindful by reinforcing that attention to the breath and giving you feedback by playing short bells to when you're concentrated, so that this really fruitful skill, but isn't always easy, a bit like going to the gym or getting sleep hygiene. It's quite a challenging habit. It gives you support in that.
Does it work?
Yes. So short answer, but try it out. Mindfulness is built on a experiential evidence base, as well as randomized control trials. But in mindfulness, people always say, give it a go and see for yourself how you feel when you pay attention to your breath for 10 minutes. I always encourage for people to be the judge of that.
Are you getting the data back from users, and is that becoming part of your PhD?
Yes, that's hopefully the long-term plan. Is we'll probably have the largest data set in the world we've already got at least 15,000 mindful breaths taken on it. We hope it will continue to grow as well.
Isn't that wonderful that you help the world to relax, and in the course of them chilling out, they help you to get your PhD?
Fingers crossed.
And for people to be able to take part, can you just tell them what to do, where they go and get a copy of the app, and how they can help Tom get his PhD?
Yeah. So it's freely available tool. You can go to Minds, that's minderthanz.com. You can download it. It's coming soon for Android, but if you've got an iPhone, you can download it right away for free, sign up, and find somewhere comfortable, lie back, and take a few mindful breaths.
And on that note, we will hopefully leave you more relaxed and more mindful, at least until next week's edition of The Naked Scientist. Thank you very much to Tom Mole, who you heard there, Nick Oscroft, Sean Porter and Dan Gordon. The producer this week was Georgia Mills. Now, next week's programme, we're going to be exploring the new telescope that's going to take over from the Hubble Space Telescope. Remember how radical that was and what a shake-up it caused as soon as those amazing images emerged? Well, you ain't seen nothing yet is what NASA is saying. We'll hear about that next time. The Naked Scientist comes to you from Cambridge University and is supported by the EPSRC, the STFC and Rolls-Royce. I'm Chris Smith, and until next time, goodbye.